Hello and welcome to Mathematics with Simon. I'm Simon. We have a new subscriber called Victoria and she asked me to make a video about mechanics, Newton's second law and lifts. So here it is. The falling lift. Imagine a 1,000 kilogram lift. The cable breaks and the lift falls down a 490.5 meter shaft. How long does it take to fall? How fast is it travelling when it hits the bottom? So we start with Newton's second law. We want to know how fast the lift accelerates. F equals ma. We want to know a. So a equals F over m, dividing both sides by m. For the record, acceleration and force are both vectors, of course. What is the force? What is F? It's the force of gravity. So the force is F equals m times g. We substitute in and then we substitute in for F, so what we get is A equals mg over m. The m's cancel, and we just get g, the acceleration due to gravity, which is 9.8 meters per second squared. Meters per second is another way of saying it. We've also got some formulae we can use here for objects which are accelerating at a constant rate. So v equals u plus at, the so-called SUVAT equations, because they involve s, which is displacement, u is initial velocity, v is final velocity, a is acceleration, t is time. V equals u plus at, s equals u plus v over 2 times t, or s equals average velocity times time. V squared equals u squared plus 2as, s equals ut plus a half at squared, and s equals vt minus a half at squared. So which one of these is the right one to use? Well, we've got distance, 490.5. We've got initial velocity u, which is 0. We've got the acceleration, and we need the time. So this looks like it's the formula with all the right quantities in it. So 490.5 equals 0 times t plus a half gt squared. Multiply both sides by 2. 981 equals 9.81 t squared. Divide both sides by 9.81. The numbers work out perfectly. It wasn't contrived honestly. So you get 100 equals t squared. Well, we want to make it work well. It takes 10 seconds to fall basically 490 meters. It's pretty quick, isn't it? 490 meters is half a kilometer. And how fast? Well, we want to know final velocity. We know the initial velocity. We know a, and now we know t because it's 10. So velocity equals 0 plus 9.81 times 10, which is 98.1 meters per second. That's really quick. 98 meters every second. If we imagine covering, it's basically covering 100 meters in a second, isn't it? And humans run, really quick humans run 100 meters in about 10 seconds. So it's 10 times as fast as the fastest sprinters. To get it to kilometers per hour, we multiply by 3.6, or we divide by 1,000 and times by 3,600, which is the same as multiplying by 3.6. We get basically 353 kilometers per hour. It's really quick. And just out of interest, well, I mean, how long would it take to travel a whole kilometer? If you released a lift, or indeed any object, in free fall, how long does it take to travel a kilometer? So here we use the same formula, s equals ut plus a half at squared, but in this case s is 1,000. So 1,000 equals 0 plus a half gt squared, times both sides by 2. 2,000 equals 9.81 t squared. T squared equals 203.9. Square root of that is about 14. So 14 squared is 196, which shows why the square root is just over 14, 14.3. So basically, if you release an object, it only takes 14 seconds to fall a kilometer. Isn't that amazing? And how quickly? Well, it'll be quicker than last time because it's falling further. Of course, all of this is assuming no friction. So we're just going to use again v equals u plus at, v equals 0 plus 9.81 times 14.3. So the velocity is 140 meters per second. So it's traveling through 100 meters in less than a second. Times by 3.6, we basically get to 505 kilometers per hour. It's super fast. So that's why it's not a good idea to free fall a kilometre, although maybe we always all knew that. I hope you all like this video. Please subscribe and hit the notification bell. We'd love to hear your ideas, and most of all, I hope you enjoy your mathematics.